John Haddock. I'm a professor of civil engineering at Purdue University. So we're on the site of a test project. It's a pilot project. It's a quarter-mile long, being built by the Indiana Department of Transportation. Technical name for it is dynamic wireless power transfer, which is sort of a fancy way of saying as you drive your vehicle down the pavement, it's able to charge the battery in your electric vehicle. Why are we doing that? Well, so two of the big barriers to electric vehicle adoption, at least for the public, are range anxiety. Oh my gosh, where am I going to charge the battery on this car? And the second thing is cost. And a lot of that cost in electric vehicles is driven by the size of the battery packs that they have to have in order to get you that 250, 300 mile range. This system, you'd be able to drive your small vehicle down it, and it would be able to charge the battery as you drive over the pavement at speed. So the speed limit here is only 55 miles an hour, but you could go even faster and it would charge the battery. What that allows us to do then is it means that now there's no range anxiety. You don't have to worry about where you recharge. The road's doing it for you as you drive. Secondly, now you can have a smaller battery pack in your car. That's going to reduce the weight of electric vehicles. So it's also going to reduce the cost of electric vehicles. So you can see how it takes two of those high hurdles for electric vehicle adoption, kind of takes them out of play. This is a one of a kind in the world that we're doing here because it's basically designed to be able to charge fully loaded semi-tractor trailers as they travel down the road at 65 miles an hour, and that has never been done. So it's first of its kind. The way the system works is that the coil in the road creates a magnetic field, and that as an electric vehicle with a receiver drives over that, as it crosses into that magnetic field, it's able to take an electrical charge from that field. So it works similar to the way you charge your cell phone at home when you lay it on that cell phone charger. That cell phone charger sets up a magnetic field. You have a receiver in the back of your phone. When you put it on it, it's able to translate that magnetic field back into electricity and charge your battery. This works in basically that same manner. So currently, we're due to have the project finished next spring. So around May of next year, we'll actually get Purdue will actually take the project back from the contractor. And when that happens, we'll start doing testing. So Cummins, which is in Columbus, headquartered in Columbus, Indiana, they actually have a couple of electric semi-tractors that they've built. They're actually outfitting one of those to bring up here so that we can test the system using that semi-tractor. So that's what will be next. We'll do the testing with the trucks. We also have a trailer that has a receiver on it that we'll be able to pull over with a pickup and do testing. What we would like to be able to do now is to test the system and try to begin to optimize it. What can we do to, to change it so that it becomes more efficient? We can make it so that it's less expensive and things like that. Driving that towards the future, I think within the next, 3 to 5 to 7 years, hopefully NDOT's going to want to try and take this system and actually put it in an interstate for an actual trial in the real world.